Hello and welcome to My Code Coffee. Java 18 final version is now available. It has 5 new features, 2 incubating features, 1 preview feature and 1 deprecation. This video gives 2 minutes summary of all these changes followed by details and examples. So here is the summary. In the category of new features, first feature is UTF-8 by default Charset. Starting Java 18, UTF-8 will be the default Charset value if you are not passing Charset in method argument. Number 2, simple web server. Yes, Java 18 provides an out-of-the-box simple HTTP web server which can be used for testing and some small tasks. It is not a production-grade server. Number 3, code snippets in Java API documentation. If you are someone who wants to put code snippet in the Java API documentation, Java 18 provides a convenient snippet tag which you can use for this purpose. Number 4 is reimplementation of core reflection and method handlers. Java 18 has re-implemented core reflection and method handlers to reduce the cost of upgrading reflection support. Number 5, internet address resolution using service provider interface. So Java 18 no more depends on platform built-in resolver for IP address resolution. Now let us come to incubating features. As you know, incubating features are those which are still in development and you should not be using these for your production environment. First feature is vector API. Java community is developing vector API for vector computations. This is third incubator for this API. Second feature is foreign function and memory API. This feature introduces an API by which Java programmers can interoperate with code outside of the JVM. Coming to the preview feature, Java 18 has one preview feature and that is pattern matching for switch. Java 18 has enhanced switch expression in various ways. And finally, Java 18 has one deprecation. Java 18 has deprecated finalization and it will be removed in future. Why this was necessary, we will see in the details. So this was the summary of all the changes in Java 18. Now let's go straight in the details of individual features. And I understand that you may not be interested in the details of all the features. So in the description, I have given the timeline so you skip those features which don't excite you. Just to be clear, I will discuss only those features which are officially part of JDK 18 and can be used in production, which means I will not discuss incubating features and preview feature. So the first feature is UTF-8 by default Charset. A charset in Java defines a mapping between sequence of characters and sequence of bytes. Java supports several charset. Some examples are UTF-8, UTF-16, US ASCII and so on. If a charset argument is not passed, then standard Java API uses default charset. Unfortunately, the value of default charset differs from system to system depending on several factors like Java runtime environment, operating system, users locale, etc. So if a Java program running in one environment writes on a file using say US ASCII charset and another Java program running in a different environment tries to read that file using a different charset, say UTF-8, then the reading program will fail and it cannot decode the text written by file writer correctly. Obviously, one of the solutions to avoid this type of data corruption is to pass the default charset as an argument. However, this would prevent method from being used via references in stream pipeline. So passing default charset as argument is not always possible. So to fix all these issues, Java 18 has provided the solution that if you don't pass any argument for charset, then default charset will be UTF-8. Let us see this with an example. I have written a very small program here which will simply print the default charset. So I have downloaded both JDK 17 and JDK 18 so that you can feel the difference. And currently my environment is pointing to JDK 17. So this is the program. It will simply print the default charset, whatever it is. So let me first go to that directory where I have this file. So it is in C, my code coffee, UTF. Okay. Let me then first compile the program. UTF demo.java and then let me run it. It is printing CP1252. Now this was dicey. Okay, as I said that in earlier version of Java, the default charset would depend on several factors, like it may depend on the operating system, it may depend on the Java runtime. So you don't know what will be the value of default charset. Okay, so it is printing CP1252 for me now. Now let me point the environment to JDK 18 and see how it affects this value. So since I'm using Windows, so I will simply go to system environment variable and change it. I will have to close this command prompt and open it again so that that change takes effect. Now let me compile the program, javac utf-demo.java. So now let me run that. Okay, utf-demo. So now you see that it is printing UTF-8 because my environment is now pointing to JDK 18. So this demonstrates the default charset value of JDK 18. Second feature is simple web server. Java 18 comes with a minimal HTTP server. This simple web server is not meant for production environment. Okay, it does not have servlet container and it can support only head and get HTTP requests. Basically, this web server which comes along with Java 18 is only for education purpose and minor testing during code development, where a small out of the box server can be helpful. You can start this server using command line tool or programmatically. So let us start the server using command line tool. To start the server, you simply write the command jwebserver, okay, and it will start the server on port 8000. This is the default port, okay. But if you want to start the server in a different port, you can do that as well. So first let me stop the server. To stop the server, you just press Ctrl C. Now let's start the server at port 9000 instead of default port of 8000. So to do that, type jwebserver, okay, and -p for port number, and let's say we want it on port 9000. Okay, so now you see your server is running on port 9000. Also, this server will serve the file from the current working directory. Let's say you don't want that and you want a different directory, so you can do that as well. So first let me stop the server by pressing Ctrl C. To change the working directory, you will have to write jwebserver, okay, and then let's say you want port as 9000, and to change the working directory you will say -d and then whatever is the working directory. So I want to keep it as C my code coffee. Okay, so now the working directory for this server is C my code coffee. Now what I have done in C my code coffee, I have placed an index.html file. I will just open this file to show you that it is printing few things. It's a HTML file. So now if I go to browser, okay, and say http localhost, and what is my port number? It is 9000, right? And then index.html. You can see it has printed the tags, whatever is written there. So this is a small demo of Java web server which comes along with Java 18. Next feature that I want to discuss is code snippets in Java API documentation. So Java 18 has introduced a new tag called snippet, and using this tag you can include source code in API documentation. There are two ways to do that, inline and external. So let's see the inline part first. As you can see, I have written here a stupid piece of code. It's a class and with a very funny function saying that if I is greater than 0, say it is positive. If it is less than 0, say it is negative. Don't worry about the code. All I want to show is how you can use snippet tag in Java 18 to put a piece of code in the API documentation. Okay, so to do that, I will first what I will do, I will go to this generate element comment so that I get this. I can type also these asterisks. Okay, now to use the snippet tag, all you need to do is start with a curly brace and write add snippet, okay, and then a space and then a colon, and then write the piece of code, whatever piece of code you want to be in the documentation. Okay, so put it here, Control V, and then since you started with the curly brace for a snippet tag, you will have to end it with the curly brace, and that's it. And now if you generate the API doc, you will see this piece of code in the description of the function. Okay, so let's create the doc, export, Java doc, finish. And this created the doc. Let's go to this index.html and see it in the web browser. And I will go to this package and click on this class. And as you can see in the description, you are seeing this piece of code. So that's how inline snippet works. Okay, but I think by now you can guess what is the problem around inline snippet. The problem is that this piece of code that you are documenting here has nothing to do with this piece of code. In fact, if you change anything here, of course it's not going to change anything here, right? So it can happen that you change the actual code but you forgot to change the code in the document. So this is the real disadvantage of inline snippet. But there is another way of writing the snippet, and that is external snippet. And we will see that that usage in my view is better, because when you do that, you don't copy the code from here to the snippet piece, but actually you just give a region, and if you make any change in the code, it will change the code in the document as well. So let's see how that works. Okay, so I will copy the same function here, and I will simply change the name of this from inline demo to external demo. So let me first create those element comment asterisks. So similar to inline snippet, you will start with a curly brace and you will write snippet, but then things change. You will give either the file name or the class name. I'm going to give the file name, and my file name is snippet demo.java, and then you will define a region. Okay, so you can give any name to the region. I will give the name my code coffee, and then close with the curly brace. Next step is that you will make use of this region to define from where to where you want the code to be part of the document, to be part of the Java doc. Okay, so to do that, all you need to do is just write start and then region equals to the region that you have defined here, and then suppose you want from here to here. Okay, so you will simply put an end here, end. So this tells you, so this is how you define the external snippet. Here what you're saying that in this file, which is snippet demo.java, put this piece of code which is with the region my code coffee from start to end in the Java doc. In case of external snippet, there is one more step where you need to define a snippet path. Okay, so let's do that. You go to export and Java doc, next, and here I will give the snippet path. So snippet path entry is like this. Okay, snippet path equals snippet path and then the full path of the file location. Okay, and then finish. Okay, now let's see. Go to this snippet demo. Now as you can see, both for external demo and inline demo, we have this description, and clearly if you change anything in the actual code for external demo, let's say I'm saying I is very positive. Okay, and you again create the doc, export, next, here is the snippet path, finish. Now it will create the updated doc. Let's see this. Now you see, you change the code and the document is also having that changed code. So that's the advantage of using external snippet compared to inline snippet. If you are using a command line tool, then the command is this, where as you can see, I mean, this is the old command for generating the Java doc, except that you will add the snippet path here so that your external snippet can work. Okay, and what I'm doing here is that for the location of Java doc, I'm giving a different folder name, because if I write doc here, it will override the whatever we have created using Eclipse IDE. I just want to show you this. So if I create using command line tool, then it will create the Java doc in the HTML folder. So let's see. I mean, because I have given HTML folder here, of course. Let's refresh it. Yeah, you see the HTML folder, and it's the same thing. I mean, no difference. I just created different folder names so that I can show you that, I mean, you can create using command line tool also. So open with web browser, and same thing here also, you see the same things. So that's how you can use inline snippet tag and external snippet tag. There are a few more features, like you can highlight some of these words. I'm not discussing that. You can refer to the document related to snippet, but these are the basic things, like how you place this snippet of code using inline snippet or external snippet. Now let's discuss the next feature of Java 18, which is internet address resolution using service provider interface. Java 18 no more depends on platform built-in resolver for IP address resolution. To understand this, let me first write a program which gives you the IP address, and then let's see what Java 18 has to offer. So let me create a new package, com.my.code.coffee.spi, and then in this package I will create a new class. Let's call it IP address. Then let's write a main function, public static void main string is, and then I will write a program to get the IP address, inet address. So array of inet address, let's give it a name. Let's call it IP equals to inet address dot get all by name. You can use, there are a couple of functions that you can use. I'm just using this one. So I want to know the IP address of mycodecoffee.com, mycodecoffee.com. Okay, and then let's print this. So system.out.println, and since this is returning an array of IP address, so let me put this in the for loop. So for int I equals to 0, I less than IP dot length I plus plus, and put this print command here. Let's call it, let's just print it. So IPI. Okay. I think it will ask to throw the exceptions, so let's throw that. Now let's run this program. Okay, and as you can see, it is returning an array of IP addresses of mycodecoffee.com. So this is the usual program that we have been writing till Java 17, and internally it is using operating system resolver to give you these addresses. Now what I want to do, I want to write my own address resolver, and I want this function to call my custom address resolver instead of calling operating system. So let's do that. So to do that, I will implement the new resolver interface that comes with Java 18, and that is inet address resolver. So let me create a new class and I will call it my address resolver. Okay, and this class is going to implements the new interface that came with Java 18, inet address resolver. Okay, and of course you need to import this. Now this is showing error because you are implementing this interface, so you need to implement all the unimplemented methods. So let's add these unimplemented methods. So in this method I will return a dummy IP address, stream.of inet address dot get by address new byte, and then just anything. So let me write this. So this is my custom resolver, and this resolver is returning me this IP address. Now next step is that I will have to write a resolver provider, and this address resolver is returned by the get method of inet address resolver provider. Okay, so let's create a new class and then you will see it. Let's call it as my address resolver provider. Okay, and I'm going to, as you can guess, I'm going to extend it from which class? Inet address resolver provider. Let's import it. And add unimplemented methods here. Okay, so this get method of this class should return the resolver that you want to use. So how you will return that? Simply return the object of the resolver class that you have created, which is my address resolver. Okay, so I have a resolver class where I have written the method which will return me some IP address which I want to be returned, and then I have a resolver provider which will return the object of this resolver class. Now by default, if I don't do anything, then this method will continue to use the operating system resolver and will give the same result which it was giving. Now how can I tell this method that instead of using operating system resolver, use my address resolver? Now what you have to do will really depend on which type of application you are writing. If you have written a web application, then you will have to create a file in the meta-inf services directory, and the file name should be java.net.spi.inet address resolver provider, and in that file you will give the fully qualified name of my address resolver, which is com.my.code.coffee.spi.myaddressresolver. But that you will do when you create a web application. But in my case, I have not created a web application. I have created a simple Java application. So for normal Java project, you will have to create the file moduleinfo.java. So let me create this file. File moduleinfo.java. I think even in Eclipse IDE, when you create this project, it gives you the option of creating this file. I might have not checked that option. So if while creating the project, IDE itself creates this moduleinfo.java, it will already have this entry where it writes like module and then the project name. In this case, it is address demo, right? Now here you will have to make this entry. Provides. First you will write Java 18 provider class, which is inet address resolver provider. You will have to write it. You will have to write the fully qualified class name. So basically write this package also. and then with the class that you have written. You have written this class, my address resolver provider, right? So write this, and this also should be fully qualified. So copy this package also. Okay, so that's it. Once you make this entry, this method will start using the resolver that you have written instead of using operating system resolver. So let's run this, and you can see that it is returning this IP address instead what it was returning earlier. So that's how you can implement custom address resolver in Java 18. Let us move to the next section. In this section, we will discuss Java 18 change where it has re-implemented core reflection API. This is the implementation level change, which means there is no change in the API. So as a developer, you will not feel any difference while coding. But let me explain what is changing at the implementation level. You see, java.lang.reflect uses VM native methods and dynamically generated bytecode stubs as its mechanism for reflective operations. Similarly, java.lang.invoke, which was introduced in Java 7, uses method handles. So in total, there are 3 different paths for reflective operations. When we update java.lang.reflect and java.lang.invoke to support new language features, we must modify all 3 code paths, which is costly, isn't it? So to address this issue, Java 18 has re-implemented java.lang.reflect API to use method handles. So now method handles is the common underlying reflective mechanism. As I mentioned earlier, this is implementation level change and there is absolutely no change in the APIs. Now let us discuss the next interesting change in Java 18, and that is deprecation of finalization. Java 18 has deprecated finalizer methods, so it will be removed in future releases. Not only that, Java 18 also provides a command line option to disable finalization because by default, even in JDK 18, it is enabled. So if you launch a JVM with this option, it will not run any finalizers. But the question is, why Java 18 has deprecated finalizers? Why we want to get rid of finalizers? You see, finalizers are used to release the resources, and garbage collectors in Java are used to release memory. If a memory is representing a resource object and garbage collector releases this memory before the resource was released, then that resource will never be released. Usually you release a resource by calling close method on that object. So idea is that one must release the resource before garbage collector releases the memory. And that's where finalizers came into picture. Garbage collector would schedule the finalizer of an object before releasing its memory. At a high level, this sounds like a good collaborative work. So if an object has become unreachable, garbage collector will schedule the finalizer will release the resources, and after that garbage collector will release its memory. So resources got released, memory got released, fantabulous. So what is the problem? Well, life is not that easy, isn't it? And a lot of good things come with lot of bad things. You will be surprised to see the list of flaws of finalization. First of all, it has some fundamental security issues, particularly if the constructor of a class having finalizer method throws an exception. In this case, though the object is not fully initialized, it will still be eligible for finalization, and its finalizer can do arbitrary actions on this object. Second problem is that it has severe performance issues because garbage collector needs to do extra work when objects are created. Thirdly, it has the problem of unreliable execution because finalizers are scheduled to run by garbage collector. But garbage collector typically operates when necessary memory is less. So if there is a plentiful of memory and less resources, garbage collector will not work and the resources will be waiting for finalization and will not be released. Last but not least, it's a difficult programming model and even seasoned programmers can do mistakes when using finalizer methods. So with all these issues, Java community decided to deprecate finalization and prepare to build adieu to finalizer methods.